Hey guys, welcome to week 2 of digital learning with Algebra 2. This week we are going to review factoring quadratics and cubics equations. There were 4 different ways that we did it. Our first two, we have basic factoring. And that was when our a value was equal to 1, and that means in our standard form of a quadratic, our leading coefficient was just 1. And then there was slip and slide. And that was when our a value did not equal 1, so it was bigger. It was 2, 3, 4, something else was leading off that equation for us. The third one was one of our special cases, and it was called difference of squares. Difference means that there was difference of squares. There we go. Means that there was a minus sign in between two perfect squares. And then the fourth one is grouping. This was when we usually had 4 terms to deal with, and we had to split them up in half. So we're going to review all 4 of these. So first thing we're going to review is our basic one. Oops, sorry. Okay, so basic is first. The example I'm going to use is x squared minus 7x minus 18. So what we did is we thought to ourselves, okay, what multiplies to give me negative 18, but it can also add together to give me negative 7. What are those two numbers? Those two numbers are going to be negative 9 and positive 2. So negative 9 times 2 is negative 18. Negative 9 plus 2 is negative 7. That's how we got to separate this as x minus 9 and x plus 2. Okay, super basic. You probably remember that from Algebra 1. Okay, we took it up one little notch when we made our a value not equal to 1. There was a little something extra we had to do in the beginning. So if our a value is not equal to 1, I did a method called the slip and slide. Okay, so I'm going to use an example of, I'm going to do 3n squared minus 8n plus 4. Okay, so this time my a value is bigger than 1. It is not 1. It is 3 actually. I'm going to slip the 3 to the end and multiply it. Okay, so we've slipped it down here, slipped my 3 down, and multiplied it on the end, which means now we have n squared minus 8n plus 12. And we can go back to the basic factoring that we just did. We think multiplies to give us 12, adds to give us a negative 8. Well, that's going to have to be n minus 6 and n minus 2, because negative 6 times negative 2 is positive 12, but negative 6 minus 2 gives me negative 8. Okay, so at this part, we're not done. We did the slip. Now it's time for the slide. So slide, divide. I am going to divide both sides now by that 3 that we slipped in the beginning. My first factor is going to simplify. 6 divided by 3 gives me 2. So my first factor is n minus 2. Our second, negative 2 over 3 does not simplify. So instead, we're going to bring 3 to the front, and it becomes 3n minus 2. So our denominator got to get pushed up to the front. The reason we do this, because remember, if I worked backwards and tried to FOIL, so if I try to multiply these guys together, n times 3n needs to give me 3n squared. If I didn't pop the 3 up, that wouldn't happen. So that's how I know that this is our final answer for our slip and slide. All right. Example 3 is going to go to difference of squares. So this is when we have 2 perfect squares, except there is a minus sign in between them. So I'm going to start with a very simple one, x squared minus 25. Difference means there's a minus sign. X squared is x times x squared. 25 is 5 times 5. So because the middle piece was missing, remember we talked about the word conjugate, it means we have the exact same thing except one is plus and one is minus. That's the only way that when they multiplied through that my two middle terms got canceled out. Okay, so to figure out what that is, we're going to do the square root of x squared, which is x, and then we're going to do the square root of 25, which is 5. So we have x plus 5 and x minus 5 as our answer for that one. All right. Of course, we like to make them a little bit more fun and not as obvious for you guys. So sometimes you might see it looking something like this: 5x squared minus 45y squared. Okay, so the minus sign definitely sticks out to me, and the two different terms stick out to me. My issue is that 5 and 45 are not perfect squares, but I also recognize that I can divide 5 out of both of these pieces. So if I actually factor 5 out and move it to the front, I'm left with 5 times x squared minus 9y squared. Now I have a difference of squares left over inside my parentheses. So 5 is still here. He's still a factor. He's just not part of our difference of squares. We know one will be plus. We know one will be minus to get that conjugate. All right, so the square root of x squared is x. All right. Next, the square root of 9 is 3. And then last but not least, the square root of y squared is y. So we get 5 times x plus 3y and x minus 3y. So this one had a GCF that we had to factor out first, and that was the 5. Then we could do our difference of squares strategy to move on from there. All right. Last example we're going to do is grouping. So with grouping, we usually have 4 terms to work with. I'm going to start with an example. Let's do AD plus 3A minus D squared minus 3D. All right, I think we can both agree that there are 4 terms here. What we're going to do is we're actually going to split it in half and deal with it first half, second half. My first half, AD plus 3A. What we're looking for is a GCF on each side. The GCF on this side is going to be A. So I'm going to factor out A out of just the first 2 terms. And I'm left with the D plus 3. All right. When we go over to the other side, what we're going to try to do is find another GCF over here that's going to result in the same thing in my parentheses. I want D plus 3 to show up again. Okay, and that's the whole point. I see negative D squared minus 3D. They both share D. I can also take out that negative. So I'm going to factor out negative D from both pieces. Negative divided by negative leaves me with a positive. D squared divided by D gives me a positive D. Negative 3 divided by negative 1 will be a positive 3. And then D divided by D means it's moved out to the front. So notice that both of these have the same piece in my parentheses, which is the whole point, because that means that is one of my factors. And the other factor comes from what I got to factor out. So A minus D is my other factor. Right? And if you don't believe me, you can FOIL this back together. You can multiply them, and you will get back our original expression. All right, let's do another one. Again, I like to make these fun. So this guy, T3 minus T squared minus 9T plus 9. Okay, looks pretty simple, which it is. But simple is different for each person. I'm going to show you how this can get a little fun for us. So again, split this in half. Looking for a GCF in my first section. Looks like they both have a t squared I could actually factor out. So t squared gets moved out. I'm left with just one t here, and I've moved all the t's out, so it becomes t minus 1. Again, if I multiply this back through, I would get t cubed minus t squared, which is what I started off with. All right, my other side, my GCF over here, looks like they both, I have a negative out. I'm going to take out a negative 9 from both pieces. Okay, so negative 9 gets factored out. I'm left with just a t right here, and then I'm left with a minus 1. Again, negative 9 times t is negative 9t. Negative 9 times negative 1 gives me positive 9, so that works out. Again, what's in my parentheses matches, which is my whole reason for doing this. So we have t minus 1, and then what we got to factor out, t squared minus 9. Now, last time we got to this point, I was done, but not this time, because this should look familiar, like something we did not too long ago. Where was it? Up here, difference of squares. Do you agree that t squared is perfect square and 9 is a perfect square? And there's a minus in between, so a difference of squares has showed up for us in our problem. So one more step. We're going to have t minus 1 still, and this guy's going to break apart into t, that's the square root of t squared, plus the square root of 9, which is 3, and then its conjugate, which will be t minus 3. All right, so there's an example of all the different ways we're going to factor. You have a worksheet posted for you to do those 10 problems, a little bit of each of these examples. Please make sure you get those done, and it is due this Friday, just like last time. Okay, so please make sure you get those done. What is Friday's date? That is going to be Friday, April 10th. Okay, so make sure you get it turned in April 10th by midnight. All right. And again, if y'all have any questions, feel free to contact me through Teams or Remind, whichever one you're more comfortable with. And I will talk to you guys soon. Thanks.